Question number 86 says, let R be the region in the first quadrant bounded by the graph, the four-coast graph, which I've drawn in red, and the parabola x minus 2 squared, which I've drawn in blue. So the region R is the base of a solid. So this region is going to generate a 3D solid. For the solid, each cross-section perpendicular to the x-axis is an isosceles triangle with a leg in region R. Okay, so what that means is that this length here represents the length that we're looking for. It's going to be the red height minus the blue height, and this represents a leg in that of the right angle triangle. So my right angle triangle then is going to look like this. So I have a leg like that, and those are going to generate the cross sections of the solid. Now, to find volume, it's always going to be area times thickness. So I need to find the area of that right angle triangle. So the area of the right angle triangle is going to be the leg squared divided by 2. Okay, so we're going to make the square and then divide by 2 to get the area of the triangle. So when we find out the volume in general for pretty much anything is going to be the sum of the area times the thickness. And we're going to integrate that from A to B. So that's what it looks like in general. In this case, the area, we first have to find the length in the region. Okay, so that green line right here, we're going to find that leg first. So that leg length is going to be the upper value minus the lower value. So it's going to be 4 cosine of pi x over 4 minus the lower value, which is going to be the parabola, x minus 2 squared. So that's going to be the leg. I'm going to take that leg and I'm going to square it to get the square area and divide it by 2 to get the triangle. I now have the cross-sectional area, so I'm going to give it some thickness, dx, and I'm going to integrate those pieces, and it looks like here from 0 to 2. Okay, so I'm going to integrate from, my bounds are going to be x equals 0 to x equals 2. So there is my integral that I need to calculate the solid. At this point, we're not going to anti-differentiate this, and we're not going to expand this and anti-differentiate this. This would be unnecessary to do that. We use our graphing calculator. So we go to our graphic display calculator, and we're going to anti-differentiate this. So we're going to use our function integral, or you can use this integral function, area function, on your calculator. And from here, if I do this on the calculator, I'm going to end up with 4.800. So the answer to question 86, this is not 4.800. Sorry, my mistake. Integrating this again. So question number 86, the answer ends up being A, which is 1.775. So that's the area that I generate, or the volume that's generated. This is going to be in units cubed. This is going to be the volume that's generated here, and I get that from my graphing calculator.